Hello, sir. Good morning. This is our AWS project on inventory management. I'm Jasha J058. Along with me in this presentation are Ninad J041, Rishit Singh J063, and Prishnika Nani J073. So, as I said, our project is based on inventory management using AWS. In our project, we have tried to incorporate multiple AWS services like DynamoDB, Lambda, AWS Amplify, Cognito, and API Gateway. So we have used DynamoDB for storing all the tables for our database. We have used Lambda to fetch the data from the DynamoDB databases and to show it to the users in the form of graphs through our website. We have used AWS Amplify. So our project consisted of HTML pages and CSS. So we have zipped them and attached it to the AWS Amplify. AWS Amplify has two users hosting the environment, and also we can create the backend on this. But for our project, we have not tried to create the backend. We have only deployed the static website using AWS Amplify. Apart from this, we have also used Cognito because we didn't make a registration page for the users on our website as AWS provides a service Cognito. So we have tried to incorporate Cognito in our project. In Cognito, we have provided with the sign-in page for the users. We have not provided with the sign-out page because inventory management is a very confidential and a sensitive subject for the users. So we didn't want to provide all the data to them. We didn't want to show all the data. So we have only provided with the sign-in. So first we created a user pool called Deadpool. In that we have provided with sign-in through username, passwords, and email IDs, and some more things. We'll show one sign-in to you in this video. Apart from this, after that, we have also attached our website link which you made through Amplify to this, and so that we can, after the sign-in is completed, we can directly launch the website. So now we'll show one sign-in to you. So that's an account which you made for Prisni. We have put it as the email. Yeah, that's the account. So now we'll give the password. Once the user signs in, he can provide his password according to what he wants. So here we are finished with the login, and here as I said, we have directly attached our website to this. So in this we have four main things which we do through this website. I'll first discuss the payment section. So here there's a add new payment option. Everything here is done using DynamoDB only. There's only one thing which we have done using JavaScript, that is the edit existing payment. The add new payment and the view table directly comes from the DynamoDB. It fetches the data using Lambda. So once we'll create a new payment, so we'll have to provide the payment ID. We have given a particular format for the month here. So November 23, and we can add an amount. So now this amount is added. We can check it if it's added correctly or not using edit existing. So now we can see that the amount is correctly added. Now your inventory management is mostly done and shown to the users using graphs. So we have provided a dashboard where we can show this. So earlier in the payment options, it was only till October 23, but now we added one more November 23 with the data 10,000. So this is directly done using DynamoDB. We have fetched the data using Lambda and shown this as a visual. Every time we run this thing, the website refreshes itself and fetches all the data. So there's no chance of error for this. Now I'll pass it on to Prishni.
Thank you, Josh. So we've done the same for managing receiving stocks, where we add a new receiving stock where we have to enter the item ID, the name, and the quantity that we want. And then we add the name of the item and the quantity. And once we click add, it will automatically be reflected in the hidden table, as you can see here. And now we can edit the existing receiving stock as well over here by just adding the ID name. We can find the item with the quantity, and we can either update it or remove it from the table. If the item is not found, there will be a alert. For the reports, this is the reports that will be shown with the items low on stock. So it will be easy for the company to know their inventory and which to restock. The another table below it is the months with high billing, showing the month and the amount of billing done in that month. And then there's suppliers bought from. We have 5 suppliers over here, and these are the 3 suppliers with the most quantity given, and all this will be reflected in the dashboard. These are our suppliers. These are the quick stats: the total amount of stocks, the total amount of payments, and the stocks made. These are the graphs that will automatically change once you edit on the following tabs. This, as Josh explained, this is our supplier wise quantity. As I said, there are 5 suppliers, and it will show in a pie chart of how many suppliers have contributed in quantity wise. And then there's another chart that will be created, compare items, where you can put 3 item IDs, and it will compare according to the quantity. Here we've put ID 1 as 1010, 1 as 1020, and 1 as 1005. Once we click on compare, you get such a chart with the quantity and the item. So this is a dashboard that will refresh and reflect changes immediately done on the website. This is a new purchase that we've added, and it will be reflected on the supplier split wise, as you can see. The remove and update function will also be reflected immediately on the dashboard. As you can see, it has been updated automatically. Now I hand it over to Ninad.
Thank you, Krishna. So now we will move on to our backend part of our project. So first, I'll start with DynamoDB. We have created three tables: purchase, payment table, purchase table, and stock table in DynamoDB. Uh, and then we have a Lambda function. We have different Lambda functions which are connected to different tables which we have created into DynamoDB as shown earlier. So the Lambda functions are add to table three. There are three Lambda functions which we have created. Now I'll explain the different functions briefly. First is add purchase. Add this function adds a new purchase record to the DynamoDB table with the specified purchase ID, item name, quantity, and supplier. Second function is edit purchase. So we can edit existing purchase record in DynamoDB table based on the purchase ID which we will provide. It updates the item name, quantity, and supplier. Third function is list purchases. This retrieves a list of all purchases from the DynamoDB table. Sorry. Fourth function is remove purchase. This function removes a purchase record from the DynamoDB table based on same purchase ID. Fifth function is find purchase by ID. This finds a purchase record in DynamoDB table based on the provided purchase ID. It also retrieves the item name, quantity, and supplier. Then we move on to the get highest quantity supplies function. This function retrieves the top three suppliers with the highest total quantities of purchases. Then we will move on to get supplies function. Retrieves a list of all suppliers and the total quantities purchased sorted in descending order of quantity. Next is count purchases. This retrieves the total count of purchase in the DynamoDB table. Next, the main part is Lambda handler. This is the main entry point for the Lambda function. It retrieves an event object containing the operation to perform and relevant data. Based on the operation, it calls the corresponding function and returns the result. The operations supported are add, edit, list, remove, find by ID, all the functions which we discussed earlier. So we can deploy an AWS Lambda function, and also we have created an API gateway to trigger this operation via HTTP requests. So now Rishit will explain the next part.
Thank you, Ninad. So we have created three different Lambda functions for our three different tables and connected each Lambda function to the different table. As you can see here, we put an IAM role that can allow us to, that connects us to the purchase table and allows us to do these tasks. Similarly, we have done the same for our add to table 1 and add to table 2, which connects us to different tables, but the functionality is very similar with minor differences in some functions. Like there's some stock quantities, it will return the sum of stocks. Here we can see that this one is connected to the stock table. So these are the three Lambda functions that are connected to the three DynamoDBs. And then we will connect all these three different Lambda functions to our fifth Amazon AWS provided service, that is API gateway. This API gateway, we have created three different API gateways for three different Lambda functions. This could have been done in a single API gateway, but it would have been very complex. So to keep simplicity, we have done three different API gateways. And in each API gateway, as we can see, we have used the post option. The post is used in all three API gateways. It is much more secure than get and is overall a better method. So after using the post option, as you can see, we have deployed this and codes is enabled in this API gateway. We can even test this with operations. So if we test this, this will return return all the items in the API gateway in the DynamoDB, and this and in the stages we can come here and see the invoke URL of the API gateway. Now this URL is what we use in our HTML to invoke all these functions. So coming to our HTML, for our table editing pages, that are the payment table, purchasing table, and the stocks table, we can see that uh, we can see that here we have an add button. So this add function we have this add button that has a call lambda function, edit, remove. So the three functions we are using is add, edit, and remove. So for adding, we created a lambda function which takes in the operation item ID, item name, and quantity, and using the method post and all the values that we got from the form, that is that the payment ID value, all the values from the form, we can perform different functions upon the different buttons and therefore get the response. And as you can see that the table that we have presented is not present by HTML, but it is actually getting dynamically stored from the DynamoDB only. It is it every time it has an event listener. Uh, it has an event listener which will, every time the page gets loaded, it completes this function called populate table, where using the operation list we get all the items in the DynamoDB. And after getting a DynamoDB using the for each command, we create a new row, and for each item, the table is appended, and therefore it is dynamically populated. This is done similarly for the payment, purchasing, and receiving tables, but with different functionalities, but similar code. Now coming to the reports table, as you can see, our reports gives us the low items low on stock, gives us the top 5 lowest items. Months with high billing gives us the top 5 highest months, and the suppliers bought from the most gives us the top 3 highest suppliers that we have bought from the most. Now, for this, we have also used a similar populate table kind of function, but instead of listing all the items, we use the lambda function such that we get the lowest quantity items, the top 5 lowest quantity items are returned, and using the similar code, we can populate the database for this. And as you can see, the API URLs are different for each one, for each lambda function. And now using the populate table, we can get the lowest quantity items for the first report, highest amount months for the second report, and this is a complex function which actually combines multiple months, like which have the similar name. It just does not show different months, it actually combines multiple months to get highest months, and we get the highest quantity suppliers, and this all populates the report table. And now coming to our dashboard, which is the index.html. As you can see in our dashboard, we have the total items in stock, total amounts in payment, total purchases made. So all that we have put in a span 1, span 2, span 3, and using a similar event listener, we can have a total amount like some stock quantities in the span 1 using that API URL. The total amount spent, which is an operation here with an API URL in that span 2, and the number of purchases with the third API URL in the span 3. So even these numbers are dynamically allocated. And now coming to our graphs. Here we take the second graph, which is a payment graph, and the get months returns us a list of the month and the amount without any labels. So here we must do certain formatting to format the data into a chronological order, because as you can see, the data here is not present in chronological order at all. It is very randomly and multiple months are present. But we have done formatting for that, and after formatting, we have plotted using canvas.js.chart. Here we can see our source of the script. Using canvas.js.chart, we have plotted a line chart with month as an x-axis and payment as a y-axis. And now the data is the payment data that we have formatted after multiple functions is the payment data. Now similarly we have done for the third URL, which is the supplier and amount supplier and amount database data which we get from the get supplies function. Now here for this we have done a similar kind of formatting, but we did not sort it because we did not need it in chronological order or anything. And after that we use a pie chart, the pie chart to make the uh, to make the chart. And here now we for our final item, which is the bar chart, where we can compare items 1001, 1002, 3. Now here hmm, the bar the bar chart, first it takes all the items from the, let me see, it takes item 1, item 2, item 3, and it takes all the items from all the values from that form. And after taking the values from that form and creating it in a list, we can use a loop to loop through all these items and use the operation find item by id. After finding item by id, we can create the list of the item names and item quantities, and using this list we can create a bar chart, and this will only be rendered once we click the compare button. So that was it with our inventory management project for our cloud. So to summarize, we used a Cognito, Amplify, DynamoDB, Lambda, and API Gateway. And the main selling point of our selling point of our website is the dynamic memory allocation and how the changes are reflected immediately and not on some delay. So thank you for your time, and go ahead.